Good afternoon to you all, and welcome to our afternoon session on database modeling and design with SQL. Okay, so let's start our session on database modeling. Today we'll be looking at the last part on the conceptual design, where we'll look at relationships. Relationships form a critical part of the database design process because that's the main thing that connects two or more entities. Anytime you are working with data, you wouldn't have to work with only one entity. Most of the time, you would have to connect two or more entities to be able to generate some report, and you can't do that without relationships. If you don't get your relationships right, most likely your data would end up being flawed. So we'll look at how relationships work with data modeling and how they could be implemented in the whole design process. So we are still maintaining our company scenario. With our company scenario, from the beginning, we identified four main entities. We said the employees, the departments, the job roles, and the projects. Now, with these entities, they have logical relationships even at the workplace or at the company. So you'd realize that every employee belongs to a department. Then an employee is assigned a job role in the company. An employee works on projects, or several employees could work on several projects. And a department controls a project. These are how things actually work within the company. It's a scenario, it might not apply to all companies. So we try to model the data to reflect these relationships that exist in the company. Relationships, we say it relates two or more distinct entities with a specific meaning. So you don't just get up and create a relationship between two entities. It should have some kind of a meaning, a real meaning to relate to. So we could say that there's an employee called Gerard. Gerard works on a project called Product X. That means that creates some kind of a relationship between the employee and the project. There's an employee called Juliet. Juliet belongs to the research department. Definitely, it is creating a link or an association between an employee and a department. This is how we generate relationships and we translate them into the database model. Now, the degree of a relationship type is the number of participating entities or entity types. So there are four main types. You have the unary, the binary, the ternary, and the n-nary. Unary means that it's only one entity that takes part in the relationship. Binary would involve two entities. Ternary would be three entities. N-nary would be any number above 3 would be n. So but the most common of the relationships is the binary between two entities. Let's look at examples of the various degrees. So with unary relationship, let's take an employee. An employee could be in a relationship with another employee. Okay, so here we are saying that there's an employee who has a supervisor. The supervisor is also an employee. So the supervisor belongs to the employee entity. That means that if you want to relate the employee to the supervisor, it is more or less an employee to an employee. This kind of relationship we refer to as the unary relationship because it involves only one entity. Then let's look at binary. Binary relationship involves two entities. Here we have a journalist and an article. An article is written by a journalist. A journalist writes an article. There are two entities involved here. So this kind of relationship, which is involving the two entities, we call it the binary relationship. As I said earlier, most of the relationships that we would identify when you are modeling your database would mainly be binary. Then we have ternary relationship. Not most people would like to use ternary. Some people like to break it down into binary, but this is how it works. It involves three relationships. There's a teacher. So in this example, there's a teacher, there is a book, and a class. The teacher recommends a book to a class. So the teacher is the one doing the recommendation. Now, what is he recommending? The book. And to who? The class. There are three entities involved, and we call this type of relationship a ternary relationship. But why do we need to create relationships in the first place? Because you have your entities, you can just collect data about your individual entities and you are good. But we want to look at why it's necessary to create relationships. The first, we say that it establishes a connection between a pair of tables that are logically related to each other. It is the relationship that connects two entities. So that is what creates that connection, so that you can connect employee to department or employee to a project. It helps to further refine the table structures and minimize redundant data. A lot of the times you'd realize that we store data and some of the data values become redundant. We keep repeating the same thing. Let's take an employee data set and the department column in the data set. Assuming there are maybe 50 people in a research department, you'd realize that under the department column, you keep on repeating research, and it creates redundancy in the data. Redundancy would waste a lot of storage space on your hard disk. So we try to eliminate this redundancy by creating relationships. It enables you to draw data from multiple tables simultaneously. So there are lots of times that when you're generating reports, you would end up combining data from multiple tables. So let's say you want to generate a list of all employees, and the report should have their department that they are working in, their job roles, and then the projects that they've worked on. In this report, you would end up combining about 4 different tables to generate your report. And you can't do this without creating relationships among all the data sets or among all the entities. Then the last one, it helps ensure data integrity, which contributes very much to database normalization. Normalization helps you to produce a quality data set or quality database. And it is the relationship that ensures this data integrity among the various entities that are storing the data. So if you're able to connect your entities well, you would ensure that your data is of good integrity, and that would flow over to the normalization process, which will ensure that your data set is of a good normalization. Now let's look at some constraints on relationships. The main one that we'll be looking at today is what we call the cardinality ratio. The cardinality ratio. We said it specifies the maximum participation of the entities. It indicates the number of times that an entity set can participate in a relationship. But this cardinality ratio is valid on binary relationships. We'll look at examples of that. There are 3 main, or people call 4 main, but they are mainly 3. We have the one-to-one, the one-to-many, or the many-to-one, and then the many-to-many. So I'll use the rest of the time to explain these 3 cardinality ratios: one-to-one, the one-to-many, and then the many-to-many. As I said, it's valid on binary relationships, meaning that there are 2 entities involved. So let's take the first one. On one-to-one relationship, we say when each entity can take part only once in the relationship, then we say it is a one-to-one relationship. An example is a manager and the department. In this, one entity is called manager, the other entity is called department. We say a manager manages one department. So as I'm saying, the scenarios that we are coming up with might not be the same thing for every company. So we are just using a sample scenario. In this scenario, we are saying that a manager can manage only one department at a time. So we say that this becomes more like a one-to-one. We can take it the other way too, to say that a department is managed by one manager. When you get one-to-one on both ends, from left to right and from right to left, that means your relationship is a one-to-one relationship. So between the manager and the department, we say it's a one-to-one relationship because the manager manages one department and the department is managed by one manager. Let's take the next one on one-to-many or many-to-one. The one-to-many or many-to-one, we combine it because it's just the positioning of the entities. If it's one-to-many and you switch the entity, it could become many-to-one. So usually it's the same thing, but I'll explain both. So when one entity can take part only once in the relationship set, and the other entity can take part more than once, then it becomes one-to-many or many-to-one. So let's take the employee and department. In this relationship, we can say that an employee belongs to a department. That is a one-to-one relationship. Every employee would mainly belong to one department. You could be working in other departments, but you are mainly assigned one department. Okay. Then we can also say that a department accommodates many employees. A department accommodates many employees. Look at the difference. The first one, we said a department, an employee belongs to one department. So that side is one-to-one. Then the second one, we say a department accommodates many employees, meaning a lot of employees would be working in a department, but an employee can work in only one department. So the second one becomes a many-to-one relationship. This overrides the one-to-one, and we end up with a many-to-one relationship for employee and department. When we switch this over, when the department comes to the left and employee goes to the right, it becomes a one-to-many. But I decided to use another example to explain the one-to-many. So let's look at department and projects. A department controls a project, or a department controls many projects, meaning that there could be several projects under one department. But we are saying that a project is controlled by one department. A project, even though there could be other departments involved in the project, it's normally controlled or belongs to one main department. So in this case, we have one-to-one from the right, then we have one-to-many from the left. The many overrides the one-to-one. We end up with a one-to-many relationship for the department and the project. This one too, we could just switch the project to the left and the department to the right, and we would end up with a many-to-one relationship. So the one-to-many and many-to-one is mainly about the positioning of the entities. If you swap the entities, the ratio would change, but they both work the same way. Now let's look at the third one, which is the many-to-many. Many-to-many, but we usually don't write M to M, we write M to N, where the M and the N are representing the many-to-many. So when entities in all entity sets can take part more than once in the relationship, that relationship is referred to as many-to-many. So this third example, we have employee in the project. An employee works on many projects. So you could have one employee working on several projects at the same time. That makes it a one-to-many relationship. Then we could have a project being executed by many employees. In most cases, a project you'd have a lot of employees working on one project, and that would also make it one-to-many. from the right. So here we have at the top one-to-many, and at the bottom many-to-one, or also one-to-many, depending on how you're looking at it. So always, when you take this one, the M overrides. When you take the left side, the M overrides. We end up with a many-to-many relationship, meaning that many employees could be working on one project, and many employees could be working on one project, and one employee could be working on many projects at the same time. That makes it a many-to-many relationship. So relationships here are very critical in modeling your data. You should be able to identify how the entities relate with each other, because that would inform the structure of the data that you store in the database. If you get it wrong, that means that you might not be able to implement it very well. Now remember, in a database, we don't just pick abstract things to store in the database. It's mainly data from real-world activities that you are storing. So the relationship that takes place within the real world should be transformed or should be related to what is stored in the database. If you get it right, if you get the model right, that means whatever data that is going into your database would end up being right. Remember, garbage in, garbage out. If you don't structure the data well, if you don't create the relationships well, that is when you start having problems, because you'd have difficulties in trying to connect one entity to another to be able to generate or retrieve some data from there. Okay, so for this session, we've been looking at relationships as the last item for the conceptual design. In the conceptual design, there were three main elements that we looked at. We talked about the entities, the attributes, and the relationships. So under relationships, we say it involves two or more entities. We talked about the unary, the binary, the ternary, and the n-ary relationship. Then we came to the cardinality ratio, which is more like a constraint on the relationship, because you need to specify how many entities are involved in the relationship at the same time. Here we talked about the one-to-one, the one-to-many, or the many-to-one, and then the many-to-many. This is it for the relationships. Next week, I'll be starting the relational data model. So all that we've been looking at is mainly the entity relationship model, how you model the entity relationship. It gives you a visual representation, so it's easier for the user to understand or the developer to understand. In the relational model, it's closer to how the data stores the data. The database stores the data itself. So sometimes we say it's more structural. It's closer to the database design itself. There we'll be talking about tuples, attributes will still be there, but most of the things can be mapped from the entity relationship to the relational model. But one main thing that we'll be looking at under the relational model is what we call the referential integrity constraint. That is very critical in every database, especially when you are creating the relationships. If you don't get it well, your database would end up being bad. So that is it for today. I will now take the questions, or if there are any discussions or feedback on the session. So if you have any question, you can just put it in your chat, in the chat, or you could unmute yourself and we'll take the questions. Thank you.
So Carlos,
yeah,
a question. Okay. We've talked about relationships. So at what stage do the teams sit together to discuss all these relationships when modeling a database?
Okay. So during the data model process, we are saying that normally you should work collaboratively. So it's good to work in within that agile framework where everybody comes on board. The developer or the data architect or the database designer doesn't just sit to create these relationships, because these relationships is a model of the real relationship that exists. So you need, most of the time, the product owner, the product manager, you would need the Scrum Master, you need the developers, you need the analyst or the business analyst, if they are consultants, or all the stakeholders that are involved. Because some of the concepts, it's not technical, it's more organizational than technical. It is the business guy who can create the relationship between the two entities. So they have to explain to the data architect that, okay, so maybe within a sales environment, a product should be related to the supplier, because it's the supplier that brings the product before the customer comes to buy. You should be able to create that link. The developer might not know all the details about this, so the whole group sits down. So once they identify the entities and the various attributes, through that, then they now create the relationships by connecting all the entities. Yeah.
So if we didn't identify the right relationship and we built the database,
yeah,
could there be an opportunity for us to go back and look at it and make any changes if we realize that we didn't put a relationship between two tables right?
Yeah, there's always that opportunity. The whole database process is iterative. You could always go back to make the changes and come back. But the problem there is, if it changes the structure of the database, that is where you could have problems when there's data existing in the database already. If there's no data, it is fine. You could always make changes. When there's data and there are minor changes, it is fine. But if the database has some data already and you need to make some major changes in the database, that could be problematic. So that's where you would have to extract all the data, try to restructure or transform the data to conform to the new design before you load it back into the system. And that would mean that it's going to cost you a lot of time, a lot of money would be spent on that. It's always better to get it right from the beginning. Okay, any more questions? Or do I take it that everybody understands the relationships of the data? William?
Carlos?
Yeah.
Hi, Carlos.
Hello, William.
Yeah, thanks for the session today. Great stuff. You know, I was just thinking on the question that Kwame just asked a minute ago, and during one of those sessions, you took us on, can't remember exactly now, but you talked about one of those modeling that allows for upgrades. You see that if you are to input the data, the system automatically connects or upgrades it so that you don't have to go to do it all over again. I can't remember exactly, but I know we talked about something like that.
Yeah, yeah.
What was that again, please?
So in the data modeling session, I think I mentioned that you could use the paper and pen, or you could use the diagramming or modeling tool, or the third option I gave was using the database management system.
It's 5 o'clock.
So I said that the database management system, you could create your model or your diagram out of the system. And because the DBMS holds the data, when you change the structure, it reflects in the model also automatically. So with that one, it's very easy. Anything you change, when you generate the diagram, it reflects all the changes and shows you the latest diagram. But when you have to create the model before you create the database itself, that is when you would always have to come back to restructure your data and go back and then implement. So there are two ways. When you are implementing it in the DBMS, that's the software that is used to create or maintain the database. It's easier to reflect the changes in the diagram, in the model. But if the model has to be created in a different platform or on a different platform before you come and build your database, then sometimes it becomes difficult.
Right. Just one last question for me. I'm just wondering, in very large organizations where a lot of data is being handled, sometimes this data has to be across multiple locations and countries and things like that. In handling such data, is it like, and this data has to be interconnected? I mean, I'm just trying to figure out or wonder how that works. You see what I'm saying? With such a huge database.
Okay.
That one change in one part of the company or something does not have, would it have an impact on the other side?
Mm-hmm. Okay, so what happens, it depends on the architecture or the setup that the organization chooses to implement. We could have the centralized architecture or the distributed architecture. In the centralized architecture, everything sits at one location. All the different locations would be connected to that one server. So when you're using different applications, all will be connected to that one server. When you make inputs, it would still come to that one server. When you need reports, it will all generate from that one server. That one is very easy because everybody connects to one. So when the data changes, it reflects on all the other places. But when it's distributed, that means that a bit of the data is at one place, another set is at another place. But what happens is that there is always that synchronization. There is always that data being moved among the databases. That system is good because it creates redundancies, and that redundancy helps in times of errors. So you can easily recover from an error or anything that happens to the database. So both ways, they all have their advantages and disadvantages, but it depends on the organization and how they want to set up. A lot of people like using the centralized database, everything connected to one. But I know some organizations also do the distributed, spread it over, but there's always that synchronization. Yes.
Yeah, thanks for that. One last one from me is that if you have such a huge data, let's say in one server, or even the distributed model you're talking about, how can such a huge data be backed up? Or is it in case of like a corruption or something?
You mean how can it be backed up?
I mean,
when there's an...
No.
What is the essence of backing up?
No.
Okay, no, come up with your question again,
Yeah. If we have such a huge data, database, and how can this data be backed up alternatively so that if anything were to go wrong, like in technology, things do go wrong sometimes.
Yeah.
So that you don't have to, in terms of trying to recover the data, is there a possibility of backing it somewhere else? I don't know whether the question is clear.
Yeah. In most cases, if you have your database and you don't back up, then it's like you're putting yourself on some lifeline kind of thing, and anything happens, you're screwed. It's always whether you are having 100 terabytes or exabytes of data, it's always necessary to back up. So the amount of data that you are storing now would now determine how much storage space you need to make available. People would like to back up on some cloud server somewhere. Others want to back up on some other, maybe hard disk or a network server. So sometimes in your setup, you have another server somewhere connected to your database. So anytime the data goes in there, it backs it up automatically. There are several ways of doing this backup. We have the full backup and we have those ones that we do incrementally. So there is always the full backup the first time. Then the incremental ones, anytime a new data set adds up to what you already have, then it backs up just the difference. And the backups could also come in various forms. Some people like to back up online, as I mentioned earlier. Then there's the on-site and there's the remote site backup. People can back up. I know some time ago, people used to back up on DVDs and all of that. But I mean, these days, most computers don't come with those DVD drives. So others also use maybe another hard disk or connected through a network, or what we call the RAID, redundant array of independent disks, to back up their systems. In both cases, you should have an on-site and off-site. Why do we need that? In case you back up at the same location where the actual data is, and let's say there's a fire or there's some flood, that means you are going to lose your original data and your backup. So it's always advisable to have a remote backup sitting somewhere so that if your main backup gets corrupted or something happens, you can always follow the remote one. And mostly the remote one, it's not like you are going to carry the data to the place. It's at a remote place, but it's connected to your main server. So anytime you schedule the backup, that some people like to do it in the night where everybody have closed. So every night, then the data backs up to that remote server. It's an automated process, so you don't need to be doing it manually.
Yeah, thanks very much for that. But okay. I mean, the next question I was going to ask you, you've answered it to some extent, which was the fact that if we use a centralized one, a server, which is centrally connected to all the different locations of the company or branches, and something were to have happened to the server, that means that anything that has to do with data is stalled till the server problem is sorted. That could be one of the downsides.
Yes, that is true. When something happens to that server, at that moment, you could have, you need to hold up and try to restore. So in most organizations, what we do is that the IT people, they try to simulate these kind of things. You try to simulate something happening to your database and how quick it will take you to restore your data back to the normal process for operations to continue. So this part of the whole risk management process, you need to preempt some of these things. Just try out something, introduce an error into your system, but not when it's in active use anyway. Not when that data set is in active use. Introduce some error into your system and see how quick you could get back into it. If you think that this thing takes a long time, then you need to look for other ways to reduce the recovery time, because it's very important.
Yeah,
in trying to recover your data back to its original state is very important.
In management, in leadership and management, we call that crisis introduction. You introduce a crisis and then people respond to it. All right. Thanks very much, Carlos.
Thank you. Okay, so I think we are going past our time. So we'll end our session here. It's been a good session. See you next week. From next week, Monday, we have our agile testing and automation. Then on Tuesday, we'll start with business agility, introducing the SAFe model. Maybe William will talk a bit about that before we close the session.
Okay, Carlos, you've said it. Next week, Monday, we have agile testing by Eric. And then Tuesday, we're starting our business agility series. We'll clarify what agile is and what's the myth about agile. Once you have that understanding, it enables us to start the beautiful journey of going on to skilled agile, where we'll spend more time. But thank you, Carlos, for this session, and see you all next week.
Thank you very much, everybody. Thank you, William. Thank you, Carlos.
Take care. Enjoy your day.
Take care. Have a wonderful weekend.
Thank you.
Thank you.
Thank you.